Okay, we're going to do a problem involving exponential heating and cooling. In this case, we'll do heating, but cooling is really the same thing. This is really Newton's law, which has been around since the 18th century, so like around early 1700s. It looks intimidating just because of all the variables, all the things you got to plug in, but basically what it says is that any temperature will increase or decrease proportionally given the difference between that body and the temperature around it, or like the room temperature around it. So if you look at the problem here, they said suppose you had a turkey at 40 degrees, so it just came out of the refrigerator, and you put it on the counter in your kitchen, and the kitchen is at 69 degrees. Of course, slowly that turkey will warm up, and according to Newton's law of heating, theoretically, if you left it out there forever, your turkey would end up becoming 69 degrees, right? So, if you kind of read down below here, it says eventually it took 25 minutes, the temperature got up to 47 degrees. So that will allow you to find the heating constant, which in this case is K. This is the one thing you got to solve for in this equation. Of course, that varies depending on what we're talking about, whether we're talking about a turkey or water or whatever the substance is. And once we find K, we're going to say, well, how long or at what temperature will the turkey be after 115 minutes, or almost 2 hours? Obviously, it'll be warmer than 47, but not quite 69. But so the thing is, I would suggest writing out the formula and then picking apart all the different variables, and they're kind of, you can kind of, the DeltaMath does a nice job in the middle of the problem to kind of highlight what everything is. And, in your science books, these variables might look a little different. Like room temperature, I always learned it to be T sub R. In DeltaMath, they call it T sub A. So the room temperature is 69. You can see I wrote these here on the right side. T sub 0, anything sub 0 is initial or original, so that's 40. Just the T by itself on the left, that's the final temperature, which for our purposes is 47 degrees. Of course, little t is time, that's 25 minutes. So the deal here is we want to plug all this stuff in, right? We got 40 here. T sub A appears twice in the problem, 69 here and 69 here. K is my variable. Little t is 25, so I'll write the T first, and then the K, and then capital T is the final temperature, which was 47 degrees. And really, we just have a lot of algebra to do here, right? You want to subtract 69 from both sides. Here we go. Of course, if we subtract 69, we'll get negative 22 on the left. Of course, we could add up these 40 minus the 69. That's going to be negative 29 on the right. And you know what? I omitted the E. That's the whole key to this, is having that E there. So let me try to make this look a little bit better. I'm going to move. Oh, come on. Oh, I got to leave that there. So 40 minus 69 is 29, and I have e to the negative 25k. Next step, that's a multiplication on the right, so I want to divide both sides by negative 29. Negative 29 here, negative 29 here. So on the left, I get 22 divided by 29, which I guess I'll leave as a fraction. You could certainly make it a decimal. Just make sure to carry enough decimal points. 22 over 29 equals e to the negative 25k. And of course we have an exponential, so we want to log both sides. And of course if it's e, the quickest way to get rid of e is actually the natural log. So I want to natural log both sides of this equation. On the right side, natural log and e, they're inverses of each other. And we actually just get the negative 25k to come on down. On the left, that's just a constant. That's some number. Again, you could find it on your calculator or do what I'm going to do. I'm just going to leave it there towards the very end. And then last step, that's multiplication. So we'll divide both sides by negative 25. And if we do that, of course, on the right, we get k. And on the left, for k, we're going to get about 0.0110501. And I kind of wrote all these out. Again, if I had a TI-84, I would just leave them in there. So when you rewrite your formula, right, the temperature of the turkey is going to be 69 minus 29. I'm sorry, 69 minus 29 e to the power negative 0.011. I guess if I rounded off, I'd have to say 1, right? T. So that's my equation. I'll make it look a little better. So that was actually part 1 of the problem. Part 1 says find k and rewrite the equation. Part 2 said, hey, what happens after 115 minutes? Well, now this is the easy part. You're just plugging in 115 for t. So I'll copy this down, negative 0.0111. Again, my suggestion is keep the decimals on your calculator. And I would type that in just as is, left to right on your TI-84. And if you do this, this shakes out to about 61 degrees. 61 degrees Fahrenheit. Again, that was Newton's law of heating and cooling. And I hope you found that helpful.